Professor Eric Wang. Eric, why he's setting up? Eric is a system professor from the UC, University of California at Santa Barbara. And he is also the head of research at a company called Stimula. Eric has done, has a lot of interesting, has a lot of a wide range of research interests from natural language processing to computer vision, machine learning, and so on, and with a particular focus on multimodal learning and embodied AI. So I will give him a couple, 1 minute to set it up.
Hi, everyone. It's very nice to be here to talk about our research on building AI agents that uses computers like human. And thanks, Joyce, for the nice introduction. And today I'm going to mainly talk about what we are doing at Similar. Right, 1,500 hours. On average, people spend 1,500 hours every year just clicking around on the computers. That's roughly 3 months of our life, right? So we are gradually become operators of machines instead of creators and thinkers. Yet today's computers were designed even long before AI was a thing. So it's time for that to change. What if computers could act on our behalf, navigating apps, filling out the forms, and so we can really focus on what's more important for us, more meaningful creative work. So we believe it starts by giving computers what they are missing, a brain. At Similar, we would like to build general purpose agents that can use your computers exactly like a human, clicking, typing, automating anything from a single prompt. It has lots of potentials. It can work across many industries, including healthcare, real estate, recruiting, insurance, finance, travel, data analysis, and shopping. Let me show you one example. All right, so we all have health insurance, but probably none of us really enjoys dealing with health insurance claims, right? And now you can ask our computer user agent a simple query, and it will navigate to the right side. Oh, it seems okay, let me open this video for you. Oh, interesting. Oh, anyway, we can skip the demo video. But basically, the agent receives the language query, interact with your computers via the most intuitive way, mouse and keyboard control. It clicks links, moves through pages, and eventually find the correct PDF. And in the end, it will present the file along with a concise summary of what happened. So behind the scene is a computer use agent framework built on top of all major foundation models, the one that tops benchmarks on browsers, desktops, and smartphones, consistently outperforming OpenAI and Anthropic on popular computer use benchmarks. And the paper Agent S also received the Best Paper Award at the iClear 2025 Agentic AI for Science workshop. And we open source everything. It receives more than 6,000 GitHub stars. All right, so let me first talk about the challenges of computer user agent, right? We condense those challenges down to 3 key ones. First, the lack of specialized and up-to-date domain information. Agents that use large language models for reasoning can quickly become outdated based on the pre-training data used by those models, right? And as there is a certain cutoff date for the pre-training models. And furthermore, the various types of interactions and options may or may not be a part of the pre-training process. Second, continual learning to adapt to new answering interfaces. As an agent progresses in a computer user task, it can go through a variety of screens and windows and applications with different interactions. So agents really need to adapt to those novelties on the fly. And lastly, most requests are long horizon tasks that require several objectives to be met before a task can be considered done. For example, here, the task could be helping me export charts, graph, and other images from this folder received in a certain email, and then upload those PNG files to a certain path in Google Drive for later use, and also use numbers to name them. Right, so to complete such a task, the agent needs to break down the full task into a sequence of subtasks across different applications, right? And even worse, large language models-based agents are highly susceptible to environmental distractions, especially in graphic user interfaces. So to solve those challenges, we can go back to the basics, right? What is something we as human what is something we can learn from how humans interact with the graphic user interfaces? And of course, those UIs are designed for human as the end users, while agents represent a totally new class of users. Yet there are still some key observations that we can utilize for developing better agents. As human, we learn from past experiences. A lot of tasks, especially on the same app or domain, often involves very similar workflows. For example, here, the task clear my history in Chrome and clear all cookies in Chrome basically share basically share the same workflow all the way up to the very last step, right? So if we know how to clear the history in Chrome, then we can apply similar experience to navigate to a similar screen in order to clear the cookies. And if the task is almost entirely new to us, then the go-to option is to search the query online. This usually provides a lot of solutions, and we might even get a step-by-step walkthrough. And even if we are in a new app, right, there are often certain interactions which are very similar, like both Google Sheets and LibreOffice Calc have a formula bar. You can select a cell and then write a formula to add all the numbers in a column. And if we are completely clueless about application, we can just explore around, right? Just look at and interact with different options till we find what we are looking for. And yeah, when we are faced with a new task on a similar UI, we can reuse this exploration experience. So we as human, we learn from experience. We learn from previous experience of solving similar UI tasks, from expert experience generated by others online, and from previous subtask experience performing specific interactions. And also, we can do continual learning. We can save new experience gained from exploration for future use. So based on those key ideas, we introduced AgentS, the open source agentic framework. At the core of AgentS is the experience augmented hierarchical planning method, right? So yeah, it's a hierarchical planning framework. We have two agents here, a manager and a worker. After receiving a new task, then the manager would basically break the full task into a sequence of subtasks. And then the worker receives the subtask and complete each one sequentially by producing a, a sequence of actions by interacting with the computer environment. And then how does agent S learn from experience then, right? So when the manager generates the plan, it performs a web search to get more updated information about the specific task at hand. It also dived into its narrative memory to find similar tasks, and this information is fused and provided as the context for the manager to do the high-level planning, generating a sequence of subtasks. And then the worker received a subtask and retrieved a similar subtask experience from its episodic memory. Know that the narrative memory stores some abstract full task experiences, and the episodic memory stores detailed step-by-step subtask experiences. And finally, as the agent progresses, it summarizes the subtask and full task experiences, and then store them back into the memory in a continual learning manner. Okay, here is an example of the planning and execution process, right? So given a task, set Bing as my default search engine. Okay, so first, the agent would like to search online, right? We can form a query based on the current observation. So in this case, we form a query like how to set Bing as the default search engine in Chromia on Ubuntu. And then next, the agent will use the search query to find a similar task it has completed before, right? In this case, it retrieved from the memory a similar task, such as how to clear browsing data in Chromia on Ubuntu. And then the agent would fuse those information and generate a plan, which is a sequence of subtasks, right? And the worker performs one subtask at a time. And in this example, it fetches a useful piece of information of using hotkeys to open certain settings, like the drop-down menu. Right. So we released Agent as the first iteration of Agent as last year, October 2024, and it achieved the state-of-the-art performance on the OS World benchmark across all categories. And if we take a look at the ablation studies for the experience retrieval process, we basically observe that all kinds of experience are highly useful for computer use agents, right? And among them, web search, aka the expert experience, and the subtask experience for episodic memory have the most significant impact. Right. So we know that experience play a key role, right? However, it's also necessary to have experience in the memory in the first place, right? So that there is a cold start problem, right? So to solve that, we perform an initial self-supervised exploration on some dummy tasks proposed by LLM, and then which don't have any ground truth labels, right? Since the experience is saved as summaries of trajectories, it does not depend on the success or failure of the actual tasks. So we can just employ an LLM-based self-evaluator to judge those trajectories. And then after deployment, right, as agent else continues to perform inference, we keep expanding the memory and save new interactions and experience into the memory while executing new tasks. Yeah, further ablation studies reveal that initial exploration is very effective for population, the repositories, and improving the performance of computer user agents. We all also know that using a self-evaluator, which summarizes trajectories instead of just storing the entire trajectory, is more helpful. Yeah, we have made some progress, right? But there was still a very long way to go. Human can achieve 72% success rate, while we only had around 20%. So what's still missing? First, many systems still struggle with pixel-wise grounding. So basically, the ability to localize and interact with exact elements on the screen. And also, there is an over-reliance on one single model, the generalist models. And those models, just try to handle everything by itself, from planning to action generation to grounding, which often results in some brittle behaviors. And this reveals a systematic flaw. We are pushing monolithic models to do too much without the necessary specializations. And actually, in our experiments, those strong generalist models may not be a good specialized models. For example, back in the days, the most powerful large language models like Cloud 3.7, SONET, and even GPT-4.5, right? They are really weak grounding models. And as you can see, a 7B grounding model, a 7B specialized grounding model can easily outperform those much larger generalist models. So yeah, monolithic models, which depends on a single model to deal with everything, it's not really the optimal setting. And can we combine the best of generalists and specialists to improve grounding and adaptation to the evolving environments? And that requires a call for more modular, more compositional system. So that's why we introduced Agent S2, a compositional generalist specialist framework. All right, so we still have the manager and the worker agents, right? And the manager and the worker relies on some generalist models for high-level semantic reasoning. In addition, we introduce mixture of grounding, which consists of different kinds of specialized grounding experts for precise and flexible grounding. And then here, at every step, the worker agent also serves as a router to select, the best specialized grounding expert for a particular subtasks. So we include a few different kinds of grounding experts, such as visual grounding expert, which selects the precise coordinates based on textual description. So basically, given a description of subtask, it can output the exact coordinates on the screen. And in addition, we introduced a textual grounding expert, which uses the OCR approach to identify and select the spans of text. So it can select some text in a very precise manner. And we also utilize, structure grounding expert to ground to and edit multiple cells in tabular structures. So here is an example on how it works, right? So let's see, given a subtask, like select the last paragraph in this document, then the agent first route this task to visual grounding expert to click exact coordinates on the screenshot and then try to drag the mouse to select the last paragraph. But you see, this is actually a very hard task for the visual grounding expert. Then it fails, right? Then recognizing the failure, then the agent self-corrects itself by writing the subtasks to a different grounding expert, our textual grounding expert, which uses OCR approach to precisely select the last paragraph in the document. And then after this subtask is done, the planner, the agent then generates a new subtask, which is to apply the format on this last paragraph. And then the agent use visual grounding expert again to click the drop-down menu to select the formatting option. Right. Well, we cannot play the video, so we will skip this. Agent S2 achieved new state-of-the-art on all kinds of computer use benchmarks, including OS World for Ubuntu, Windows Agent Arena for Windows, and Android World for smart mobile phone use. And with the release of Gemini 2.5 Pro, then it achieves 41% success rate within 50 steps. So the agent ads framework is really agnostic to different foundation models. So with a better foundation model release, you can expect better results from our framework. We try our best to make it scalable and compatible with all the new advances. Well, as we have pushed agents' capabilities forward, right, we made some progress in grounding, interaction, and learning from experience. But one challenge keeps rising to the top: planning. And this chart shows the breakdown of the agent failure modes, right? And as you can see, over 40% of failures stem from planning, far more than any other categories, right? So that means, agent increasingly understand what to do and where to go, but they still struggle at figuring out how to get there. And in other words, the core bottleneck is no longer perception or grounding anymore. It's reasoning. So with the new advances in large reasoning models like O1, O3, R1, all those kind of reasoning models, we make a major revision of Agent S. Right? We release Agent S 2.5, which allows more flexible context engineering. So we remove the rigid hierarchical planning framework and gives the agent more flexibility to do things. And this fully unleashed the power of those reasoning models. And then now, with Agent S 2.5 basically achieved a new state-of-the-art, about 56% success rate on the OS World benchmark. So we haven't released any tech reports for this, but it's already open sourced. So just go and try it. All right, some key takeaways. First, a compositional framework which consists of generalist models for reasoning and specialist models for grounding outperforms any monolithic models. It is better to distribute the cognitive load to specialists and let the generalist models operate in a purely semantic reasoning space. Just let them do what they are good at, right? You don't really need to have the strongest models to get the best performance. And in our experiments, we show that a well-motivated modular framework can help you get there with minimal cost, even with some inferior models. If you combine them in a good and intuitive way, it can outperform a single strongest model. All right, so we are a company. Similar is a company. So we are not just crushing numbers on the benchmarks. So it doesn't just work inside the sandbox, right? So we are actually building real world computer use agent products. And so far we have released quite some products, similar Pro, browser, similar cloud, and similar for business. So for all kinds of users. So okay, similar, if you would like to skip the setup of the open source agentic framework, AGS, then just try our cloud solution. If you are a pro users, let's see, if you have some specific use case already in mind, like if you are a startup founders, you work for small medium businesses, then try Similar Pro. And Similar browser is an agentic browser that allows for more exploration, right? All of them are free to download and try. All right, what's next? So here I would like to quote something, David Seaver and Richard Sutton had said earlier this year. Welcome to the era of experience. We already did some initial work about learning from experience, but it's far from done, right? There are a lot of things to explore, like how can we incorporate experience without a rigid structure, right? Can we equip agent else with agentic memory? Can we do something even smarter? And also, so the current reasoning models are still not the best, and they are not particularly trained and fine-tuned for computer use agents. Right? Can we enable more grounded long horizon reasoning, particularly for computer use or some other agentic tasks? And finally, can we build self-evolving agents by learning from experience? So we don't have to manually configure the context. Then it could just learn by interaction from the experience to improve itself on its own. All right, thank you so much.
We have a question, time for one or two questions.
Okay. Yeah, the question is about the memory mechanism, right? So basically, it's like a rack system, right? You have a storage for all those experiences, and that's your memory, right? We use LM to summarize the experience into natural language queries and like the key and values, and then save it into the rack system, right? Then we calculate the embeddings of the keys and retrieve the similar ones by calculate the similarity.
Yeah, more on that memory thing, like what exactly do you store? So that's like, do you summarize the entire trajectories into something more reusable, or would you store the trajectory as it is and feed into the LLM? So that's one part. And the other part is also like, this agent seems very highly capable. Congratulations on that. Did you also see how it behaves in safety scenarios?
So, okay, the first question is about again, the memory mechanism. Okay, so we store two kinds of experience, full task experience and subtask experience. For the full task experience, we use LM to summarize very high level abstractive information. So it's like one or two paragraphs of the whole trajectory. And for the subtask experience, we save the step-by-step information. It's more detailed. So it's like, at this step, you do a certain action one, next step, action two. So more detailed. But no screenshot, no other information, just natural language summaries. What's your second question again? Oh, yeah. So yeah, safety is indeed a big problem, and in our company, so we basically because our product can be downloaded locally, right? So all the informations, all your personal information won't be shared to the cloud. So you can save all the information on your local device. So that's so since it's already on your computer, if you already okay, so that's for the private concern, right? So if you have your account, you have your accounts logged in already, then yeah, everything is fine. If not, then we can still resolve to you to input the private information. While for other safety concerns, yeah, so that is an open question. Like,
Hi, so my question to you is, why do a lot of these computer use agents insist on using the computer like a human through a GUI when there are so many more natural ways for LLMs to interact with the computer through terminal or DOM if using the browser? For example, the task that you showed earlier for formatting a Word document would be much faster and more reliable using code. So
yeah,
why
that's
not?
a great question. Yeah, that's a great question. So, the distribution of the real world task is like this, right? So for those highly fragmented tasks, yeah, there are often APIs provided. But for the majority of the task, right, we have a long tail distributions. There are basically no APIs available to utilize the websites or applications. That's the most of the tasks. And then computer user agent provides a more general way to deal with all kinds of tasks. Right? So eventually, if you target everything, then it could be a hybrid computer user agent and other API calling agents. But yeah, only computer user agent can deal with those kind of tasks on the long tail distributions. No.
Okay. Yeah, thank you.